Hi guys, this is GK from GK Marine Tech. Today there is a third chapter from electricity, and up to now we are talking about the direct current, which is actually invented in 1800 years. So that time Volta, the scientist Volta, Alessandro Volta, he invented this. After 1855 years, 1855, Tesla, Nikola Tesla, he found this alternating current. So he proved that alternating current is very advantageous, and we are using nowadays mostly all the machinery from alternating current only. So a lot of advantages of compared to DC, AC is very best. Okay, now we will discuss about what is AC, how it is formed, and what are the things to be discussed about the AC. Okay. Okay, first direct current. We already discussed in the first video. So direct current, how from one atom to another atom, how the electron is moving, and current opposite direction, how it is moving. So just for refreshment, we are going to see the path of the electrons. So this time I did with the PowerPoint animation. Maybe this is better than before. So one copper wire conductor I have taken, and inside I put lot of atoms in the series. So how the electron is moving from minus to plus, what is moving, and plus to minus, what is moving. Okay, this electron, this valence electron, how it is moving, the same time that atom become positive, that positive how it is shifted. So we will see now first electron is moving left side, but the atom become positive, it is shifting from left to right. Okay, so atom is moving from right to left, and that means minus to plus, and the positive charges is moving plus to minus. Okay, so the same thing if you draw in the curve. So now I show only the voltage. So current is that I already told you, it is the quantity, number of atoms. So starting one atom will move, then two atom, then three atom, four atom, like that it will increase in the middle. Then after that it will go in the same speed. Okay, so if you are representing this current movement, we are not talking about the electron movement. Now the current movement we are plotting in the diagram. Okay, this diagram, vertical axis I took it as amplitude. Amplitude means for volt also same vertical line, and current also same vertical line. Only the value positive will be in the upper side and negative will be in the bottom side. And this x-axis we are taking with the time, because every second what is happening, how much volt is there. So that one we are making a graph. This is how the graph is coming, you see. So if you switch on, if you started moving the electron from starting, it will start from the zero, right? So I shown red color, it is the voltage. This is the voltage, and the same time I shown the another line, that is for current. This is a quantity. That means starting it is a zero quantity, then slowly increase to the quantity up to how much we required for the load. So after that it is steady. There is no difference. So voltage and current curve, there is no lagging, no difference. It is the steady line. That is the beauty in the DC, direct current. Okay. So now AC is just opposite. It is having varying this current and voltage periodically. So, but directly we cannot use that. Some motors and all we are using directly. Some electronic equipment we are converting into DC, and then we are using. So converting DC, AC to DC is very easy, but converting DC to AC, it is a big task. Okay. So if your supply, your supply all are AC only. So wherever you want DC, easily you can convert and use the DC. Okay. So this is the direct current. Already we talked a lot of things about this. Now we will shift to the alternating current. Alternating current, you see the same conductor. Now we are passing alternating current. The symbol is like this. Why is this like this? Because our AC is, the pattern is sine wave. Even we have a square wave, we have a sawtooth wave, a lot of waves are there, but our power supply purely sine wave. Sine wave we have a lot of advantage, and smooth also. So that is why we are using power supply AC in the sine wave. We will talk about that, why this, the waveform is like this. Okay. So now what I am doing, only the positive charges. Now we are going to talk about the current. We are not talking. We are not going to talk about the electrons. So current, how it is moving, you see. Same time, I am plotting the speed of the electron plus number of electron. Number of electron I am not showing here, but it is very similar. When the speed started increasing, the same time number of electron also will started increasing from 0 to maximum how much the load is there. Okay. So how it is going, you will see. Sorry. See, now the positive charge is moving in the other side and coming back. It is not continuously going in one direction. It is going some distance and return back. Okay. So now, not like a direct current, in one direction only that charges are moving. Here periodically we are changing the direction of the charges. Okay. So once again I will show you. See, the positive charges is going to the some distance and again it is coming back to the original. So like that it will keep on moving forward and back. Okay, forward and back side. So that this is called alternating current. Alternating means it is going forward to the left side to right side, that is the positive direction, and right side to left side is the negative direction. Okay, so this keep on changing. Changing in the sense in the distance you can calculate, or otherwise normally we are calculating the time basis. With particular time it will travel from this side to that side, and after that particular time again that movement will stop and again it will change the direction to the reverse to come back to the original position. So in this way, if you are transferring the current, you can transfer very long distance, kilometer, miles and miles of distance you can transfer without loss, without very less loss. If you transfer the DC directly to the one direction, then lot of losses are there. So that is why we are using the alternating current. So alternating current I am plotting here. You can make out here. I plotted here. Vertical axis as usual, it is an amplitude. That is a volt and current. Okay. Positive volt will be in the top and positive current will be in the top side of the horizontal line, and bottom side is the negative current and negative voltage. Okay. So negative direction means it is coming reverse. Positive means it is going forward. Okay. Okay. Now how it is going? The red color line, it is not like a DC. No, DC like a straight line. But here initially 0 volt. After few seconds, the voltage slowly increasing to the maximum volt. Then again the voltage slowly reducing to the 0. Then now this is the forward direction. Then reverse direction started. So reverse direction I put it the graph in the negative side, and again the negative side the values keep on increasing in the negative direction, then it is coming back to the 0. Okay, so this pattern is still continuing like this, it keep on continuing. But if it is the same pattern, it will keep on continuing, then one pattern we call this as a cycle, because the same whatever happened in this cycle, this is going to happen to the remaining cycles. So we will discuss about in AC, we will discuss about only one cycle. So that is understood. It is the same pattern we can calculate for the next rest of the cycles. Okay, that is why I made it only one cycle. I will show you. See, like that it will go. We keep on go. But we are bothered about one cycle. If you study, that is enough. What is happening in that? So one cycle means is the 0 positive. So we are not taking this as a cycle, because after that negative direction is going. So negative after negative, the same pattern is repeated. So this we call it as a cycle. Okay. So this is the time scale. So how much second, in how many seconds or how many microseconds the same pattern is repeating, we are calling it as a frequency. Okay. So frequency means in 1 second how many times this same pattern is repeating. Our AC is repeating 50 times. Okay. So 50 times means 50 frequency. The frequency unit is frequency unit is frequency unit is hertz. Hour is 50 hertz. Okay. So our power supply generally in the ship is sometimes 60 hertz also is available, and sure we are having this 50 hertz. Country to country there is a difference. Okay. So this frequency means the same pattern of the waveform, it is keep on repeating. So we will talk about the one pattern, okay, one section which is repeating. So one section is keep on repeating. So the graph representing like this is very difficult. Actually, we have to represent a different manner with the degree, because this is keep on going to come back again. So if you draw this cycle for 100 cycle, it will keep on going. No, we cannot draw in the lengthy diagram. So for that, what they are doing, this is the normal 2D graph, vertical line and horizontal line. Horizontal line is the time, vertical line is the amplitude. Amplitude we can use for voltage or current, but because this one, the cycle is going to repeat. So what we are doing, instead of this lengthy manner, we are making this a circular manner. Circular manner, instead of time scale in the horizontal direction with mm by mm, this is a distance, no? This is a linear distance. The time scale is put it on the linear distance. Here time scale put it on the degree. So why degree? So because after 360 degree, again it is coming back to the same position. So we are taking the one frequency plot in the 360 degree. That is very important. You have to understand why 360 degree, because this should be in the mm, no? Or otherwise it should be in the second. But we are not calling it as a time in the second. We are calling it as a degree. That is a very, very important. We are not measuring the time. We are putting the time scale, but we are not measuring the time. We are making the degrees. Why it is degree? Because of this cycle keep on repeating. So better to put it in the circular manner with the degree change. So now I am going to change 0 degree to 360 degree. One cycle has to finish. Again it is started 0 to 360. Again the second cycle will come. This keep on rotating. You will keep on, the cycle will come. You see how it is coming, the similar same way, same pattern, how it is representing in the 2D diagram. See, the time scale is revolving and the amplitude is going up and coming down and going up and coming down. This keep on continuing. So representing degree because of this only. So one direction is going up and coming down in 180 degree. Remaining 180 degree, it is going the negative direction maximum and coming back to 0. Okay, the same one we are putting here. You see, it is going up to 180 degree, here 180 degree and here 360 degree. You see here, this portion, this is 180 degree. You understand? This is 180 degree and this portion 180 degree. So total, where it is coming? Got it? This is 180, this is 180. So total 360 degree. Again repeating. Actually we are calling it degree because of this. Because the cycle is keep on repeating, no? So that is why we are calling it. Actually happening is in this one. This every degree you see. 90 degree is the maximum. This is the 90 degree. This is the 90 degree. This is a 90 degree. So 90 degree will be the maximum current and maximum voltage, and 180 degree will be 0, 270 degree will be the maximum in the reverse negative direction and it is coming back to 0. Okay, this is the representation of that. Now you understand why we are calling it as not in the seconds and we are calling it as a degree. If it is 360, if it is finished means one cycle is completed. Got it? So I think it is very clear. So now we will push on to the next slide, how to calculate the current and how the current is varying, we will see. Okay, now I connected one AC source with one regulator. Now regulator is off and I put one bulb, AC bulb. Okay, now no power supply is there. So, but see, voltage is there. That is what I said, even without current, voltage will be present. Got it? So the regulator we put it very minimum. So there is no bulb is glowing. Okay, so the required amount of current is not passing through that. So bulb is not glowing, but the voltage is still there. Okay, so voltage is there, but with zero current, it is possible. Okay, so now the current I mentioned in the yellow line and voltage I mentioned in red line. Now I am slowly increasing the regulator so that our bulb will get brighter and brighter. So brighter means it is consuming more energy. That means more current. Voltage is same. Voltage is not varying. Okay, but now I am increasing. See what is happening. See, I increased. Bulb is glowing. The current curve is slowly increasing, but voltage curve not changed. This you have to understand. Okay. So how much we are increasing? See, some more increasing. The voltage current curve only increasing. Voltage curve is not changing anything. There's a two different curves. This curve now it is only resistive load. Next chapter we will discuss about this inductive load and capacitive load. What will happen? These two. Voltage curve no problem at all. The current curve will behave funny in the inductive load and capacitive load. If now resistive load no funny. Actually whatever happening in the voltage curve, the similar pattern the curve is coming. Okay, this is the same phase. It is called same phase. There is no difference between these two curve. Only the amplitude different. Amplitude is different. Now this is amps, this is volt. So definitely that way vary will be there. Okay. So this is the method. Now still more I am increasing. See, the current went to the maximum. Above this it will not go because the bulb required only that much current. If you increase also there is no change in the bulb glow and then there is no change in the current. Now you understand how the current is changing. But current is changing, maximum current, but it is changing from 0 to maximum, then 0, then negative direction. This is happening. So in between we are getting three places, no current, no voltage. No current and no voltage. So this zero current, this is a zero voltage, zero current. Nothing is there. That means it look like switch off. This switch off, what will happen to the bulb? We will see what is happening there. So before that, this bulb, how much power it is taking? So power formula, what is that? Power formula. Power formula. Voltage into current. Voltage into current, and there is no phase difference. So only simply voltage into current. So if you multiply voltage into current every places, here is this much current, this much voltage. Here this much current, this much voltage. Here this much current, this much voltage. But both are in negative. So if you multiply minus into minus, it will become plus. So power always in the plus direction. Shall we see? See, power is always in the plus direction. That means the power from the source, the bulb is taking the power. The bulb is not giving back any power. You can ask, what is that, sir? Giving back. How the load will give back the power? Of course, inductor and capacitor, it will give back the load. Mainly inductor. Inductive load, it will give back some power. That is a loss. That is going to discuss in the next chapter. So, okay, now it is a resistive load, so don't confuse that. There is no difference in the current phase and voltage phase. So we can make it the power diagram very easily. Why the power diagram all in the positive direction? Because plus into plus, plus current into plus voltage, plus power. Minus current to minus voltage, plus power. Again plus. It's a mathematical funda. So that is why the power is coming in the plus. Power is plus means source is giving power to the bulb. Bulb is not giving back, return back any power. That much if you understand, it is easy. Okay. So now we will see this zero power. Here is zero power. That time what is happening to the bulb? See, now I am starting zero time. What is happening? The bulb is switch off and switch on. See, you see the zero. When it is crossing the zero, the bulb is switching on. Voltage is coming to zero and then coming up. This is AC voltmeter. That is why it is not going in the reverse direction. It is showing in the one direction. Got my point? So the bulb is switching off actually. But anytime you saw this one is switching off, the bulb is stopped and started. No, because this frequency is 50 hertz. So 50 times is one cycle is having 2 times. So 100 times. Here one time stop, here one time stop. So every cycle the power is stopped for 2 times. So we have 1 second, our 50 hertz frequency, 100 times the bulb is stop and stop. You see, one frequency 2 times it is started and stopped. So the bulb with 1 second, 100 times it is on and off. But our eye more than 20 times, any flickering is there, you cannot observe because our eye is having some storage power. So whatever you see the eyes, few seconds it will be in your eye only. You know it. So our eye can recognize less than 20 seconds, 20 hertz, less than 20 hertz. Any variation is there, you can easily notice. Okay. For example, 20. So above, then now it is 100 hertz. 100 times it is switching on, switching off. So there is no that flickering. The flickering is there. If you take a high-speed camera and you take the video, you can see that flickering. But in normal eyes, you cannot view that flicker. That is why the bulb look like continuously glowing. Actually, it is not continuously glowing. It is switching on, switching off 100 times, 100 frequency. Okay, per second, 100 times it is switching off and switching on. So this you have to understand. So I think this today's chapter, this is enough for regarding the alternating current and the difference in the DC and AC. Advantages I told you, AC can long distance can take the power supply with minimum loss, and the motor AC motor is very easy to start than the DC motor. So AC a lot of and we have with the AC we can make a 3-phase also, different phase also. That all future videos we are going to see. DC nothing else, only DC. Okay, but AC has advantages also there, disadvantages also there. That one how we are overcome, that future videos we will one by one we will see. Okay, this video I think guys, this video is very helpful to you to understand the AC, alternating current, and which one the first invented, DC. After 55 years, Tesla invented this alternating current and he proved that alternating current is the best. Now after that, all the system is running on alternating current, there is no DC power supply. Otherwise, initially they supply both. In EV, from electricity board, they are supplying DC voltage also, they are supplying AC voltage also. After that, they stop the DC. Okay, because DC, they have plenty losses. Okay, now you got the, I think you got on good information from this video. Continuously monitor, and we will see you soon in the next good topic having electricity. We will catch you later the next video. Thanks for watching.